Hello guys, in this session we will see how to calculate equivalent resistance in a circuit with resistors connected in series and parallel with ease. When we get a circuit with main resistors, we may get confused which is series and which is parallel and from where to get started. I hope I can make it easy for you. So sit back and relax, I'll make it easy for you. Keep in mind current splits between branches of a parallel circuit but not for a series circuit. So if the current splits, then it's a parallel combination and not a series combination. Okay guys, now before moving to the problem, we can check the formula for series and parallel connections. Okay, this is the formula for series connection. You can see here R1 plus R2. We have two resistors and simple aggregate sum of the resistance is R1 plus R2. Okay, then coming to the parallel circuit, if you have only two resistors, you can use this formula. It is equivalent resistance is equal to R1 into R2 divided by R1 plus R2. And if you have more than two resistors, then you can use this formula. It is 1 by equivalent resistance is equal to 1 by R1 plus 1 by R2 plus etc. up to how many resistors you have, then you can add it there. Okay, like 1 by R1 plus 1 by R2 plus 1 by R3, like that. Okay guys, now we can move to our first problem. Here we have three resistors, okay, R1, R2 and R3. Okay, R1 and R2 is at the top and one is at the bottom, R3 is at the bottom. And at the first look we can see R1 and R2 is in series, okay, and one is at the bottom, so there may be a chance to arise the doubt that R3 is parallel or series. Okay, so I have already told you when current splits, then it is a parallel connection, else it is a series connection. So we can just draw the flow of current. I hope all of you know that current flows from positive to negative. Okay guys, so we can start from here. Okay, current is moving from here and here there is a bend, but this is not a branch. Okay, current have the only way to flow to here, to this way, so it is flowing this way and reaching the resistor R1. There is no other branch, so I'm going to this way and moving to our resistor R2. Okay, here also there is no other branches, so our current will flow through R2 and here there is a bend, but this is not a branch. Okay, current have the only way to go down, move down, so and coming here and here also there is a bend, but this is not a branch. Okay, and when reaching the R3 there is also no other branches and all, so current will move through this R3. So we can say that these three resistors R1, R2 and R3 are in series. Okay, as the three resistors are connected in series here, so we can write the equivalent resistance is equal to R1 plus R2 plus R3. Here we can see R1 is 50 ohm, R2 is 100 and R3 is 200. So we can write 50 plus 100 plus 200, that is equal to 350 ohms. Okay guys, this is our second problem. Here we got three resistors R1, R2 and R3 and we want to determine whether it is series or parallel or a combination of both. And so we can start by traversing through the current flow. Okay, we can start from here, that is positive side of our cell. Okay, just starting from here and here there is a bend, but we don't want to mind it because it is not a branch and the current moves to here. Okay guys, now when reaching here you can see there is a branch here. Okay, the current reaching here can move to this way or this way, so this is a branch here. So R1 is parallel, we can say R1 is parallel here and the current will move to here, and also the current reaching here can move to this way or this way. Okay, so R2 is also parallel connection. We can say that the current passing to R1, R2 and R3 are different, so this is a parallel connection. So as our resistors are connected in parallel, our formula will be 1 by R1 plus 1 by R2 plus 1 by R3. If you have only two resistors, you can just write R1 into R2 divided by R1 plus R2, but here we have three resistors, right? So 1 by R1 plus 1 by R2 plus 1 by R3 is the formula, and if we want to assign the values here, our values are 50, 50 and 200, so 1 by 50 plus 1 by 50 plus 1 by 200. And 200 is LCM here, so 4 times 50 is 200 and writing is 4 plus and 1 times 200 is 200, so 9 by 200. And please don't stop it here, our answer is not 9 by 200, we want to take the inverse, so 200 by 9. You just calculate the value and get into the solution. Okay guys, I hope you are clear with it and we can move to our third problem. Okay, and here there are 6 resistors, and this is little bit complex. And also here there is a chance of series and parallel combination. We can check it. Okay guys, now we can start traversing through the circuit starting from the positive side. Okay, consider this current is I. Okay, just consider the current flowing from here is I. Okay, reaching here. When reaching the R1 there is no other branches, so R1 is series. And when reaching here you can see there is a branch. Okay, to this side and this side. There is two-way or path for current to flow. So I'm just calling this as I1 and this as I2. Okay, so just consider that this is I2 and this is I1. So the I1 is flowing to here and to here. You can see when reaching the R3 there is no other branch, so the same current I1 is flowing to R3, and you can see there is no other branches here, and reaching the R4 there is also no other branch. So here we can see that the same current I1 is flowing through R2, R3 and R4. So we can say that this is a series combination. So we can find the equivalent resistance of this combination, that is R2, R3 and R4. I can call it as RS1. Okay, so you can see here RS1 is equal to 4 plus 3 plus 1. That is our combination 4 plus 3 plus 1. It is equal to 8 ohms. Okay, now I had just combined R2, R3 and R4 as RS1 here with 8 ohms. Okay, now it is a single resistance. Okay guys, now this is our new diagram, and I'm just start traversing from here. The initial current I am just calling it as I. Okay, it is flowing to here. Okay, and there is no branch here. Okay, so R1 is series here, and when reaching here you can see there is a branch. The current can move towards this side or to this side. Okay, so I am just calling this as I1 and calling this as I2. Okay, so different current is flowing through this side and this side, so we can say that R6 and RS1 are in parallel. We can write the formula for two resistors in parallel. I had already told you, if we have only two resistors we can write R1 into R2 divided by R1 plus R2.
So we can write the 1 into 8 divided by 1 plus 8. We can see here our resistors are 1 ohm and 8 ohm resistors. We can write 1 into 8 divided by 1 plus 8, that is equal to 8 by 9.
And sorry for the printing mistake here, this is 0.88 ohms. It is very small. Okay, here I have just redrawn the diagram. You can see here just combined R6 and RS1. We have already got here the value 0.88 ohms. So yeah, I just combined here. And also I have just named RP1 here, no issues. Now we can start traversing this circuit from positive side. Okay, I just call this current as I. Okay, and the current flowing through R1. Here there is no other branches, so the current will flow through R1. This is series. Okay, and here the same current I is flowing through RP1. There are no other branches and no splitting of current. And the same current I is flowing through R5. So here we can see that the same current I is flowing through R1, RP1 and R5. So we can say that the circuit is in series. So for series connection, what is the formula? Yes, for series circuit our formula is R1 plus R2 plus R3, and you can see here 2 plus 0.88 plus 2. Yes, 2 plus 0.88 plus 2, that is our, here our R1 is R1, R2 that is for RP1, and R3 here that is R5. Okay, so based on our main diagram, that is you can see here R1, and here we have summed it to RP1, and here our R5. Okay, hope you understand. Okay, and when taking the sum we will get 4.88 ohms. I hope you enjoyed this section guys. If so, please like this video and consider subscribe my channel. If you have any doubts regarding this section, feel free to contact me. See you in the next video. Till then, bye.